Good morning, Dallas. Good morning, US, and good evening, India, and good evening that to Kanpur today. And this is your host Rajiv Kulkarni bringing you yet another edition of Global Electronics Manufacturing. That is electronics manufacturing and the details engaged in the electronics manufacturing. And we bring every week one guest and one topic about the electronics and that is used in the electronics manufacturing. And today's topic, as you must be already knowing, that we put it on the poster as well as our YouTube link. And before that, I would like to thank all the supporters, all the audience that you watch the show. And we just have begun this show, the talk show, only 3 weeks back. And we have conducted 3 beautiful interviews with our design architect, Mr. Amba Prasad, so far. And today's guest is a very special guest that you will hear about him and you will hear from him about today's topic. And before that, Sandeep, thank you very much for creating a nice scene as always and helping me on the back end. And Sandeep Sadanandappa runs his own A&V Perspective audio visual company based out in Bangalore. And if you have any request, if you have any requirement about the audio and visual and that you want to set up for your event, then Sandeep is the answer for you guys. And Global Electronics Talk Show is basically meant to bring any topic in the electronics manufacturing market segment. That is, it can be consumer electronics, it can be aerospace, it can be medical electronics, automotive electronics, and so on and so forth. We have started with the design, and today we are touching a subject called advanced semiconductor packaging. Yes. For that, we have a special guest, and I just will give a brief intro about him. He did his engineering, and he worked in Intel Corporation in the United States, and now he is the assistant professor in the Indian Institute of Technology in Kanpur, that is in the state of Uttar Pradesh up north. Welcome, Mr. Nilesh Badwe, and to our show, Global Electronics Talk Show this evening. How are you today, Nilesh?
Hello, Raju.
Yes,
Thank
how are
you.
you?
Thank you for the thank you for the introduction, and I'm doing very well.
Very
Thank you
good,
for
very good.
the opportunity to share the activities that we're doing here in India to promote to enable semiconductor packaging design systems related industry. So thank you very
thank,
much.
thank you. I should thank you that you are a teaching professional in the one of the most reputed institute in India, that is Indian Institute of Technology in Kanpur, and uh, with the busy schedule, you have given us some time to talk about the advanced semiconductor packaging and how that is impacting the semiconductor industry. I mean, we'll talk about that in our next session in the coming week. But before that, we need to address what is the efforts happening in the Indian market and also how your role as a professor in the advanced packaging in the IIT Kanpur is helping it. But before that, just for our viewers, tell us about yourself, your background, sir.
Thank you. So I I did my undergrad from IIT Bombay. That was back in 2008. After that, that was in metallurgical engineering and material science. So that is also something is whenever we think about semiconductors, people think
Yeah.
about electrical, electronics engineering, but materials, chemicals, mechanical, that is what we have been even pushing as we go through our discussion today. I'll let you know, but these branches, these aspects are extremely important in enabling semiconductors, equally important to electronics engineering. So as I was saying, I did my BTech from IIT Bombay in metallurgical engineering and material science. After that, I went to Arizona State University. I did my PhD in material science and engineering there. And that was where I started moving towards semiconductor packaging. And what happened was during my PhD, I worked on a project that was funded by Intel Corporation. So I was in Arizona. Intel Intel's packaging R&D hub is based in Arizona in Chandler. So through that, I got introduced to semiconductor packaging. I was working on a project. As part of that project, I even did a couple of 6-month long internships in Intel. So that was a very good introduction to corporate culture as I was studying, right? So uh, after I graduated, after I finished my PhD, I joined Intel as a full time. I worked there for about 5.5 years, some part in a few months in Arizona, and then after that, I was based in Hillsboro, Oregon. Once after that, I moved to IIT Kanpur. I joined IIT Kanpur as an assistant professor in February 2021. And since then, I've been trying to promote this field in India, trying to all those efforts started even before the India Semiconductor Mission ISM was established by the government. That has given a lot of push to the efforts that few of us in India were
Yes,
working. So it's
that is true.
been a
That is
wonderful
true.
journey so far, and I think we'll see. Sure, it's
No,
going to
you. In
get
fact,
us.
your background seems very interesting because coming from IIT Bombay with the metallurgical background, and as you rightly said, semiconductor means we often misinterpret or misunderstand that it is only electronics, but no, semiconductor does involve a lot of materials in that, and who have gone through the semiconductor background, they will definitely understand that very well. In fact, way back some 25, 30 years back, I did work for a semiconductor company back in India, and before moving to this country, and I know exactly how the wafer gets manufactured and so on and so forth. But coming back to the present day scenario, semiconductor is definitely extremely a very solid integral part of electronics, any electronics that we talk today. I mean, you talk about aerospace, we talk about smartphones, you talk about automotive, everything, any electronics, definitely an intelligent chip is a must. And the more and more the electronics design are getting highly dense, I would say, because the people have become very smart. Not only the gadgets, because the gadgets are getting smart because of the people, and people have started designing so high dense circuits, right? And because of that, the chips are getting really dense, and due to the fact that there are so many applications engaged in today's smart world, I would say. So now a step backward, right? What exactly semiconductor packaging means? I mean,
So
in brief, yeah.
I I teach a course here on semiconductor packaging. The very first slide that I show is a few boxes, and I tell students that whenever you think about packaging, you think about this, but this is not what we are going to talk about. Semiconductor packaging is, of course, I mean, all of us know semiconductors. You have silicon wafer where you put all those transistors, you create your devices, but uh, any chip, right? You cannot really we don't walk everywhere with all these different different chips in hand, right? So if once the chip is manufactured on a wafer, before you can interact with her, it goes through lots and lots of process, and these are all very advanced process that the chip has to go through before it goes into a system where a human can interact with it. So all of these aspects are called semiconductor packaging, where the main aspects include the main reason that we have to go through all of this is we need to create interconnects, move all of those tiny interconnects which are at nanometer scale on a silicon chip to a PCB, and then the PCB can go on, of course, inside your system in a laptop, mobile phones, wherever uh, the final application is. And along with that, we also need to protect that chip from corrosion. We need to provide mechanical provide mechanical protection. And then one of the very most important hot topic is thermal management, right? It creates a lot of heat, so you have to take all
Correct.
of that. So that is
Correct.
all of these things are part of semiconductor package.
Wow. Very well explained. And now, why it is so important in the electronics industry? Of course, you
So
explained part of it.
yes, now I think more details I'll certainly share next week. But
Yeah.
as you know, right, currently the Moore's law is slowing down our most advanced chips. All of those are the length scales are in the range of few nanometers. So you are close to atomic length scales. You can't really squeeze in more transistors. So the idea is instead of putting the entire system on a single chip, right? You can, that's the advanced packaging. That's where the advanced packaging concept comes. Chiplet based architecture is being promoted now by all the major semiconductor industries, which means you take all of these different functions, you create smaller chips, which provides you higher yield, which is more economical to produce. And then you put all of these chips in a single package. Now,
Mm.
in order to have very fast communication between these chiplets or smaller chips, you need to have 2.5D, 3D heterogeneous integration, 3D, 2.5D architecture, 3D architecture. That means you need to put the chips on a some kind of substrate, and then they communicate with each other very fast, or you stack them on top of each other, which is like 3D architecture where they can communicate each other even faster. But all of these advanced packaging techniques, they come with their own challenges in terms of mechanical reliability, in terms of heat management. So that is why packaging is becoming more and more important these days in order for all the electronics to continue to move forward at the pace that it has been moving so far.
Excellent response on that particular question. Obviously, for the viewers, we would be talking more in depth detail about semiconductor package, advanced semiconductor packaging next week. But Nilesh, tell me that semiconductor, the IC chips, and these have become a very so-called trending words. These at this moment, globally speaking, and how are we? I mean, when I talk about we, means about India, because you are based out in India. So how is India is now placed on the semiconductor front?
So, as you know, with the creation of India's semiconductor mission, right, the government of India has already started moving in the direction of being self-sufficient. Now, it's going to be a very long journey. It's not going to be easy, but for that, the entire academia industry, all of them have to come together to enable that ecosystem. Now, what that means is, as you must have read the news that government of India has already approved five different facilities in India. One which is a semiconductor fab, four others are ATMP OSAT, or that
Okay,
means packaging related facilities.
correct,
Now,
correct.
in order to enable those, all of these are going to need highly skilled workforce. They are going to need they're going to if they want to foster or they want to move forward in India, right? They need to have R&D facilities. They need to have trained workers who know what manufacturing and how to resolve the challenges and how to take it to the next step.
Hmm.
So for all of that, what we are doing is with the help of, or rather, all of these initiatives have been started by Professor Rautumala. In packaging world, he's extremely well known. So he's emeritus professor at Georgia Tech, and he's advisor to the India Semiconductor Mission as well as the ministers, electronics ministers in India. He has been helping the government to bring, or rather evaluate all of these proposals to ensure that we get right facilities in India. We get the companies who come to India and establish their manufacturing in India. So at the same time, what what we are doing is we have started a program called DSPS, which is focused on, it stands for Design, Semiconductor, Packaging, and Systems.
Mm-hmm.
And the goal of all of these efforts are to build the nation with a nationwide, India-wide program to enable next generation technologies and to educate workforce. Now that includes all the way from uh, operators to, which are, let's say, 12th or ITI passed technicians, all the way to PhDs who will be working, who will be ensuring that all the technical aspects are handled well. Now, our aim is also to bridge the gap between industry and academia. One of the biggest challenge is in terms of R&D.
Mm-hmm.
Very small part of R&D efforts, whatever happens, actually gets translated into product. So our aim is to bridge this gap. And for that, what we have done is we have started extremely industry-centric R&D efforts. And in these efforts, we have at this point more than 50 faculty
Wow.
from across different IITs, ISC, NITs. At the same time, we have more than 20 companies across the globe, not just India. So our aim is to focus on global R&D, and we have large number of companies across the globe who are part of this, who are interested in participating in these efforts. Then we are currently working with the government to enable these efforts, excuse me, so to enable
Okay.
these efforts in India. For that, what we have done is we have identified 12 different strategic research areas which are focused on, which go all the way from design to final system.
Okay.
And among these 12 different areas, we have faculty leads from different IITs, ISC who are handling that. And as part of these, we are planning to establish what we are calling as Industry Co-Development Center, ICCs, at 12 different places in India, where the entire aim will be to work on projects
Mm-hmm.
which are relevant to industry needs. And while doing that, typically in academic institute, as you know, right, working on
Yeah.
project means students are
Yeah.
going to work on it. So while this is something that I have personally experienced when I was doing my PhD, right, having
Yeah.
that immediate interaction or interface with industry helps you learn a lot of different set of skills
That is
than
true.
what you typically get in a purely academic environment. So our aim is through all of these efforts, educate workforce, create large number of BTech, MTech, PhD students who ultimately all these companies coming to India, they are going to need these. So they can immediately hire who can help them build these companies. At the same time, uh, all these R&D is going to be focused towards industry centric or whatever industry needs are. So we can also help industry to work towards or develop new products, they develop next generation technologies.
Excellent, excellent. I think
There
that's a
are
very, very well said about how India is gearing up towards the semiconductor, I would say semiconductor park itself, because when you mentioned the 50 different institutes they are coming up, whether it's IIT, IISc, and so on and so forth, that itself is a huge uh, manpower, highly skilled, huge manpower strength, I would say. That's like a huge the brain exists there. And uh, uh, and also, as you rightly mentioned, government plays a very important role in terms of development of market. Let's take a quick break and let's come back, the role of IIT Kanpur on today's semiconductor industry and the growth of semiconductor industry in India. Welcome back to the Global Electronics Talk Show. Every Friday, we have this show bringing in different people from the industry and different people talking about the electronics, manufacturing industry. The idea is to share the knowledge. Idea is to share the technical knowledge and also about the market segment that is happening across the globe. And today we are talking about the advanced semiconductor packaging in the electronics manufacturing. And we have Mr. Nilesh Badwe, who is the assistant professor from Indian Institute of Technology in Kanpur. He holds a metallurgical degree from the Indian Institute of Technology in Mumbai, and then he has progressed his study skills or learning skills in the United States, and then he worked in many big corporations, and now he is based out in Kanpur. Welcome back to the show, Nilesh, after this small break, and we have been talking about how India is placed now on the semiconductor market segment from the manufacturing perspective. And so I know that IIT Kanpur is engaged heavily into the advanced packaging system. So tell us something about that.
Okay. So at IIT Kanpur, uh, actually semiconductor related efforts and in general electronics related efforts started long ago. We have a lot of expertise here in IIT Kanpur in electrical engineering, computer science, mechanical, material science, a lot of expertise. IIT Kanpur actually, we have a National Center for Flexible Electronics that was established in 2014, 10 years ago. And here, aim of this NC Flexi is what we Flexi Center is as we call it here, is to conduct R&D in large area flexible electronics. That's again, it's also extremely industry oriented. So a lot of projects are focused on product development directly. Along with that, there is a large amount of R&D that goes on. And one big advantage of having uh, this center or for any industry getting involved in the center is it typically gets a matching grant. So matching grant from the government, from the Ministry of Electronics and IT. So any project that we typically run here, we get certain funds from industry, and then the matching grant comes from the government. So uh, there have been a lot of successful startups that have been initiated through this center. Now, beyond that, we've started, as I mentioned, my own area of research is focused on interconnect materials, interconnect technologies, reliability aspects of it, and that includes both first level, second level interconnects. And my own work actually at Intel was heavily focused on development of SMT paste materials.
Okay.
Good amount of work was focused on low temp solder alloy development, where I worked with multiple material suppliers, and we developed a lot of solder paste with leading companies in across the globe, which were low temperature, less than so which where you can enable 180 to 190 degrees Celsius peak reflow temperature SMT. Now, after coming here, some of my work is also focused on that. We have a lot of support from industry in India as well as across globe. So we have already initiated couple of CSR projects. So for those who don't know, there is in India there is a concept called corporate social responsibility.
Mm-hmm.
So typically companies with certain size, they have to spend 2% of their yearly profit as part of social responsibility. And one of the avenues is providing these funds to educational institutes for skills development. So as part of that, we received a good amount of funds from McDermid Alpha. It's I'm sure all of our viewers know who are in electronics business. They are one of the leading material suppliers. So with them, we have established a thermal reliability laboratory here in IIT Kanpur, which includes a thermal shock chamber, aging baking oven, very advanced FA techniques like we have advanced digital microscope with excellent resolution. Then all the FA related techniques are relevant equipment are part of this lab. Then there is another CSR projects that we have initiated with NMtronics India Private Limited, where we are planning to set up a center of excellence in electronics manufacturing and skills development. So it's going to house state of the art entire SMT line, and then we are going to start skills development programs here, where if anybody wants to train any technicians, operators, or any engineers on advanced processes, this type of facilities can be utilized for that. Then we are also going to use this for R&D efforts. We are going to use this for any prototyping or NPI type support to industry. So these are the major projects that we have initiated, and other R&D activities I'll mention. But if you have any comments, I'll just
Yeah,
wait for.
my immediate question would be: are these services that you are providing, whether it's NPI or prototype to the industry that you mentioned, is it only limited to semiconductor market segment, or is it like little bit a broad spectrum?
No, it's a broad spectrum. I mean, these type of facilities, wherever they have utility, we can look into that and we can provide these supports. So right now that the thermal reliability laboratory is almost ready. So we'll start using that probably within next month or so. The SMT line, it will take some time to establish, but once we have that, of course, I'm going to announce it and probably let you also know to announce it on on your.
Absolutely, absolutely, absolutely.
Uh,
That is
yes.
where that is what this platform is meant for, to let people know what is happening in the electronics market segment. Yes, you mentioned thermal laboratory. Is it basically when it is ready means you are ready to test the IC packaging by using certain thermal materials? Is that what you're saying?
It has a thermal shock chamber. That
Okay,
means we can do thermal shock testing. So
okay,
it's mainly focused on thermomechanical reliability. The
okay.
idea is majority of the failures, like more than 95%, 95% of failures in electronics are driven by
Thermal shocks.
thermomechanical fatigue, your CT mismatch, coefficient of thermal expansion mismatch between
Yeah,
silicon, rest of the materials, PCB, packaging. That's what
right.
leads to
The failure.
failure of this component. So the idea is to study and identify if there are any weak links in your system before you put it out as a product.
Excellent. So now you can proceed with the next, whatever the R&D centers you are mentioning. Yeah.
So actually, one more facility that we are envisioning here is a semiconductor packaging laboratory for skills development. So there is something called Indian Institute of Skills, Kanpur. It it is focused on different type of skills for a technical technician operator level. As part of that, there are uh, deep skill technology laboratories that are going to be established at IIT Kanpur campus. And one of the verticals is semiconductor packaging laboratory. So that's also one of the ways that we are planning to help the industry to generate workforce, as well as help them with any kind of R&D activities, any kind of training activities. Now, beyond that, as I mentioned, my personal focus has been on interconnect materials. So currently, the research area that I'm focusing here include again low temperature solder development, solder material development, then understanding the effect, mechanical properties, high temperature deformation, how the materials fail at interconnect level. That includes both second level as well as first level interconnect. So we have collaborators across not just in India, but outside India as well, in US, in Taiwan. We are working with them to study some of these mechanical properties of these materials so that they become ready for industry to use, or we can use some of these studies in creating simulations to understand life of a product, or ultimately basically designing the packages.
Okay. Very well, Nilesh, and I think we are almost coming to the end of the show. Would you like to add any specific message for our viewers?
So again, I think at this point we are getting started in this journey to enable these to start semiconductor packaging systems related uh, efforts in India, and this cannot happen without strong close collaboration between academia and industry. So if our viewers are from academia, I'd like to invite them to be part of these R&D efforts. If our viewers are from industry, I'd like them to be part of our efforts to guide guide the academia to help you. And there are so many different ways that industry can help. One of the slides do talk about it. Our viewers can certainly watch it, pause, and look at the different ways that we are envisioning industry can help us, help the academia, and academia can help industry. So
Excellent. Excellent. Thank you very much, Nilesh, and thank you very much, the viewers. And just a small disclaimer: whatever the presentation is being presented today is solely responsible of our guest, and under their consent only, we are presenting the presentation. And the second thing, Global Electronics wanted to mention here is please do subscribe to our channel. That way, you are able to listen and watch very interesting talk shows in the coming weeks. Every Friday, we bring this 30 to 45 minutes depending on the subject, depending on the topic. So do not forget and to log in next week the second part of advanced semiconductor packaging, again by Mr. Nilesh Badwe, assistant professor in Indian Institute of Technology in Kanpur. As he mentioned, Indian Institute of Technology Kanpur is geared up to provide you all kinds of semiconductor advanced packaging, whether it can be NPI testing methodology, whether it's a thermal lab or thermal shock or thermal cycle testing methodology, or you can talk about NPI in the small semiconductor SMT turnaround or prototype turnaround. Definitely they are gearing up and they are geared up pretty much partially, and in the coming months they will be geared up completely, and we will let you know that. In the meantime, we wish you all the best, and please do take care of your health, and if health is there, wealth is there, and time is money, as we say. So please do watch Global Electronics talk show every Friday, and please do subscribe. With that, thank you so very much for your time, and wishing you all the best, and have a very, very good weekend. Thank you, Mr. Nilesh, for your time, and we will be coming back again next week at the same time. Thank you very much.
thank you, Raju. Thanks. Bye.